Hey everyone, we're going to graph the function f of x is equal to 4x divided by the quantity x squared minus 1. The first thing that we're going to tackle is the domain. So I'm going to take x squared minus 1, I'm going to set it not equal to 0 and say, hey look, x plus 1, x minus 1 can't be 0. So x cannot be plus 1 minus 1. It can't be either one of those values. Now, since the numerator is 4x, they don't cancel out it doesn't cancel out, they don't reduce. That means that we have vertical asymptotes at x equals 1, x equals negative 1. There's vertical asymptotes at both those spots. We've done the domain. Let's take a look at the zeros. For this function, it's got a 0 at 4x equals 0. So that means x equals 0. When x is 0, this whole function is 0. Cool. What about horizontal asymptotes? Well, x squared over x, right? Let's grab this color. We'll do x over x squared reduces to 1 over x. And that goes to 0 as x goes to infinity, and it's approaching it from the top, right? And it goes to 0 from the bottom as x goes to infinity, goes to negative infinity. Pardon me, goes to negative infinity. There we go. So that's a pretty good idea of what's going on here. Do we want to get an idea of maybe what some points look like? I think that's pretty good too. I'm going to look at f of 2. That's going to be 4 times 2. You know what? Let me just... There we go. Get rid of that stray mark. 4 times 2 over 2 squared minus 1. That's 8 over 4 minus 1. 8/3, which is 2 2/3. Alright. And if I've got f of negative 2, we're going to have negative 8 over 4 minus 1. So that's negative 2 2/3. I wonder, f of negative x is equal to negative 4 over, or negative 4x over x squared minus 1. Almost. No, as a matter of fact, it is negative f of x. How about that? This thing is odd. That's useful to know, that symmetry. So I think we're ready now to go ahead and graph this. I'm going to pull up my axes and I'm going to mark off my vertical asymptotes, right? Mark off the first vertical asymptote at negative 1. We mark off the second vertical asymptote at positive 1. Next, our horizontal asymptote is at 0, so let's mark off that horizontal asymptote at 0. We had our actual 0 at 0 here, and then we want to take a look at the points we had. F of 2 and f of negative 2. F of 2 is 2 2/3. So here's 2 2/3, f of 2. And then f of negative 2 is negative 2 2/3. That's about right there. Okay. And we know this is going to approach 0 from below. We know this is going to approach 0 from above. So what's going to happen as we come in towards 1? It looks like it's going to have to go to infinity because I'm coming from this point and I'm approaching a vertical asymptote. So I can either go down or I can go up at this vertical asymptote. And I think it has to go up at the vertical asymptote as x approaches. 2 is positive, so not 1, but like 1 and 1/2 would be positive as well. This would be positive if it's greater than 1, so that's going to be positive 2. This is going to be positive if it's greater than 1. This is just always going to be positive if it's less than -1, I'm sorry, over in this range. And this will be negative, so as we come in this way, this is going to be negative, and it's going to be coming down. Okay, in between, this is what we need to know. In this region, what's happening? Well, we are either going to come up and strike 0 and then go on, or we're going to come down, strike 0, and then go on. I think it's going to be one of those two things. So what I'm going to think about is I could grab a calculator and actually compute out f of 1/2. But what I'm going to do for that is I'm going to think in the top it's going to be positive, and in the bottom it's something like 1/4 minus 1. It's negative. So this is in the negative region over here. So over here this is negative. It's got to be going down. Likewise, f of -1/2. Up top that's going to be a -2. And down below it's something like 1/4 minus 1. That's also negative. The whole thing is positive. It's going to be positive up in here. Awesome. So I think we've got the behavior pretty well set. I'm going to come in from here. I'm going to strike this point and go down. Great. I'm going to come down from here. I'm going to strike this point, come through, and go down. Come down from the top, strike through this point, and then come through and around. And I think we just went ahead and we graphed our function. Great job, everyone. I'll see you next time where we'll do some more.